quickly review what we did last time, right? We talked about the ideal amplifiers. You might feel that I keep repeating looks trivial, but once I put it in the exam, I'm sure half of you will not get 100% when I ask that question. So that's I really want you to understand what's going on. Like this time, I asked you about the type of the amplifier, common source, source follower, common source in question 3. Many of you did not do it right because maybe you get nervous. Otherwise, if you follow what I told you before, find out where's the input, where's the output, what type of transistor it is, you should be able to get them right. Okay? And we reviewed this in the class also for the current mirror of two amplifier, right? And so I feel that you should ask question now if you have question, right? If you feel this is trivial, please go ahead before I give you the answer. So we have 4 amplifiers. One is voltage amplifier. And it's very normal you have 4 because in here we only care about 2 types of signal, voltage and current. So it must be voltage in, voltage out, voltage in, current out, current in, voltage out, current in, current out. Only 4 types, right? Cannot mess up. So we can have input voltage, output voltage. The main point is that when your input is voltage, then you are a sensor. You try to sense the signal, right? So what is a good sensor for the voltage? The input impedance must be infinite, right? Then when I output the voltage, I am the voltage source. Then what should be my output voltage? Output impedance, sorry. It must be 0. Last time we derived, I showed you, right, what is an ideal sensor, voltage sensor, ideal voltage source, right? So I hope that you understand this. And of course, you know that the gain is V out divided by V in, and it is unitless, right? Then we come to here, which can be confusing. We feel very strange. We don't see it often, but we can do that. It exists. There's no reason why we cannot do that. We take the current as the input. So we are sensing the current. And then we are outputting the voltage. So we are voltage source. Think about this as you are the amplifier. You are standing here, right? Do not look in this direction. Don't care about what's the previous generation or next generation, right? You are here. That's why you are sensing the current. So you want to have 0 input impedance, and you are outputting the voltage. You are the voltage source, so you want to have 0 output impedance. Make sense? And then the gain, of course, is V out divided by I in, so it's a trans-impedance amplifier. And why is trans? Because you have two different terminals when you do this calculation, right? So similarly, now I'm this amplifier, I'm sensing the voltage. So I voltage sensor, I want to have infinite input impedance, and then I want to have 0 output impedance. Sorry, I'm wrong, right? Infinite output impedance, because I'm a current source now. I'm no longer a voltage source. I'm a current source. Okay, and finally, you have this current amplifier, sensing current, and then outputting current. So when I sense current, I want to have 0 input impedance. Outputting current, I want to have infinite output impedance. Now, there is always a way to memorize it, right? I cannot memorize this table, but there's something I feel very confident. For example, I always remember sensing voltage need infinite impedance. Then just the rest is just what? Okay, then how about sensing current? I know that it must be opposite. Then I want to have 0 input impedance, right? And then how about for output? I know it's opposite to input. So if my voltage, for sensing voltage, I need infinite input impedance, then outputting voltage, I want 0 output impedance. Because in the derivation, we remember the source and the sense are opposite, right? And then so they are all opposite to each other. Eventually, the table is correct. Think it this way. Okay, any questions? Then we talk about how to model the long ideal operational amplifier. What we need to do is just change the infinite and zero input output impedance to finite. And that's it. And that is what we put there. We can take an example. For example, the trans-conductance amplifier. It is sensing the voltage, so I want it to be infinite. I'm sensing the voltage, right? And outputting the current, output impedance also need to be infinite. But because of the non-ideality, instead of infinite, I actually have finite R in, and instead of infinite output impedance, I have finite R out. Right? And similarly, you do the others. Is that okay? Any questions? Right? If I ask this in the final, will you be able to answer? Right? Not messing up with the table or whatever. Of course, it won't be that simple, right? But I will give you a real circuit. You map to this circuit and tell me what are the input and output impedance. Okay, if no, then let's look at